Okay, good afternoon, everyone. Welcome to one more session of Computational BIM Webinar with Graphisoft. This is the second session. I will explain later how you can access the previous session. So today we'll have the pleasure of having Jorge Benitez, Chidambaram, me, and Marcelo, our colleague Rima and Carlo. So Jorge Benitez is the MD and from the director and founder from Enzyme, and together with the rest of our team, we're going to bring you this session about BCA Computational BIM with Graphisoft. So just a few house rules before we go ahead with this. I would like to ask you all to mute your mics in case we get to the Q&A session. You feel free to come up with your questions. If you want to write your questions, meanwhile, you can also write them on the chat portion. It's good if you can identify yourself with the name so that we know how to address you.
We're here. I'm using the magic.
Yes. So I would also like to ask my colleagues to mute if someone joins and is not muted. Okay. So.
Okay.
Okay. Now let's go into the session itself. So this is, as I mentioned previously, is the second session. The focus is on digital fabrication. So this is in line with a government initiative of IDD, Integrated Digital Design. So it comprises of 4 stages. The first one is on digital design, second stage on digital fabrication, then on digital construction, and on digital asset delivery and management. So if you follow us, you can see that we will post the dates tentatively. They are here on the calendar. So the next session will be at the end of February, and then we'll have the last session in May. So in today's agenda, we will have computational BIM for manufacturing. So this is focusing on how we can leverage on a set of tools to aid the manufacturing process. So we will have on this chapter Jorge Benitez from Enzyme APD and Carlo Riveral from Graphisoft Singapore, Malaysia presenting. Then we will have a break, 15-20 minute break. And then later, my colleague Chidambaram from Graphisoft Singapore, Malaysia will show you how to use computational BIM for MEP, followed by our colleague Rima that will show you how we can use ArchiCAD and Power BI to take advantage of the database that is generated on a BIM model. After this, we will have the Q&A session and the discussion. So please put your questions into the chat so that we can go through them later on with you. So for now, and for those who are joining and are not familiar with Graphisoft, I have a few slides to show you just some basics of it. Basically, ArchiCAD was founded, Graphisoft was founded in Hungary, and ArchiCAD, the first project, came out in 1984. So this is the first product that was designed, and the idea from day one was already to be 3D virtual environment software that would solve the buildings and geometry. Then we were joined the Nemetschek group in 2007, and with this we joined the biggest European software group in the AEC industry. Today we're present in more than 100 countries, mostly with distributors and some subsidiaries. So we are very glad that we have in Singapore a direct subsidiary, Singapore and Malaysia, so we can support our clients directly here. So just a little bit about Nemetschek. We're also present globally. in over 67 locations. We have many users, many brands, and the idea is that these brands are all focused on the same AEC market, and you might know a few of them, but in Singapore and Malaysia, we represent directly ArchiCAD and so Graphisoft and Solibri. So moving forward, what was our vision since the beginning? And it's very in line with this IDD, was to have a virtual building. So we're even acknowledged by being the first ones coming out with this idea, the virtual building concept. And with one building, we want to cover the whole building life cycle. We want to coordinate, we want to get the information modeling, all the collaboration done within this virtual environment. So pretty much building virtually before building in real life. So for this, we have 3 main tools that are part of our portfolio. So we have a BIM authoring tool, which is ArchiCAD. Here is where we generate the data. So where we generate the BIM model. We have BIM Cloud, is where we can collaborate. So basically connect many different ArchiCAD users into working in one single file, one single project, one single database of the building. And then we have the BIM data access coming out from Graphisoft BIMx. We can read the data that was generated with ArchiCAD that was done in a collaborative environment using BIM Cloud, and it can be accessed anywhere by anyone, even without very special BIM knowledge. So in terms of our solution portfolio here, we also add up a few more tools like Solibri and Twinmotion, and even the Rhino Grasshopper connection. So each one of these tools have a dedicated focus. So I already mentioned about ArchiCAD, BIMx, and BIM Cloud. So Solibri is used mostly for regulatory approvals and rule-based checking of the model. We have Rhino and Grasshopper connected to ArchiCAD for computational design, and today we'll see a few workflows on this. Twinmotion for real-time renderings, animations, and VR. And we even showed previously other tools like Param-O that are to generate parametric elements inside ArchiCAD. So basically today we'll focus within this circle here. We'll also have some external solutions. So stay tuned to see what we have to present to you. If you want to access the previous session, you can scan this QR code or go to our YouTube. There's a link for part 1 and part 2 of the first session. So just scan the QR code or do a snapshot, and you can look for the video name that you see here. And we have part 1 and part 2. And I think that with this, I would like now to call on the stage Jorge Benitez from Enzyme APD to go with the first part of the presentation. So Jorge, I will make you presenter now. You can please turn on your camera.
Thank you, Marcelo. Can you hear me okay?
Yes. So you are now presenter.
Okay.
So how's everything? Good? Welcome. Good morning there, because here is already afternoon.
Good morning. Good morning.
Yeah.
Okay. So good afternoon, everyone. Good morning for me, because I am in Madrid right now. Just 1 second. So thank you, Marcelo, for your presentation. I'm very excited to be here. Thank you for inviting me, Graphisoft team, and thank you all of you for spending the afternoon with us. Today we want to talk about the computational BIM for manufacturing, and I'm gonna share a few project case studies, and I want to also give you a very practical example of how, from the design perspective, because I'm an architect, so we can aid the manufacturing process with some simple actions or some simple scripts using Grasshopper and ArchiCAD. So my name is Jorge Benitez, as Marcelo said before. I'm an architect from Spain, and I, together with my colleague Eugenio Fontan, we founded Enzyme ABD in 2015 in Hong Kong. We are first of all designers. We're architects by training, and we have become some sort of digital consultants and BIM technology advocates with our practice. So we started the company with the dream of changing the architectural industry, and we were very astonished of seeing of how inefficient was the AEC industry when we had access already to really interesting technologies. So we were using ArchiCAD since school, and we decided to try to push the industry by using BIM, but most importantly, using BIM since the beginning, from the beginning of a project. Now we have grown to a small, medium-sized company. We have an office in Singapore, small office in Singapore, Hong Kong, Madrid, and Ho Chi Minh City, and we have done projects in practically every continent. We consider ourselves as a global company, even if we are 10 people at the moment, but we do projects everywhere thanks to the technologies, thanks to using the tools, and we do these projects successfully. This is the team. As I said, we have the Hong Kong office, we have an office in Singapore, Ho Chi Minh City, and Madrid, where I am right now. And this is just an overview of some of the projects that we've been working in the past 5-6 years. So we work from the largest scale, so master planning, to architectural scale, museums, residential buildings, small family homes, to the interior design scale. So you can see here a few co-working spaces, some residential and offices, and we work in all these projects using ArchiCAD, no matter the scale. So in any of the scales, we can leverage the power of using BIM. And as I said, our main focus is to push the use of BIM and technology up into the design stage. We use these smarter workflows in our own projects, and then we teach what we learn to both educational institutions or companies that are interested in learning more about how to improve their processes. So an example of this is our collaboration with Kenaka, the design build company. They are over 10,000 people all over the world, and they were interested in implementing ArchiCAD in their design team. So we established this 2-year collaboration working in different projects. For us, Graphisoft, ArchiCAD is the backbone of our workflow. So everything that we do starts and ends in ArchiCAD. And within the project, we also use many other softwares. Mainly, we move between ArchiCAD, Rhino, Grasshopper for BIM authoring, and we use actively Solibri for BIM collaboration and quality control. And we are now transitioning from a more traditional way of visualization. In the last 3 to 4 years, we have moved more into the real-time visualization, so Twinmotion and Unreal, while we use BIMx for most of our presentations and sharing our files with our client. And also we try to use, we're very keen on doing better architecture and more sustainable. So we use the tools that are available, like Eco Designer, that it's a tool from Graphisoft, or tools within the Grasshopper environment to do environmental analysis and optimization processes. At the same time, we're believers in the Open BIM concept, which is that we can, by working properly, we can work with anyone, and most of our partners and collaborators work in different software platforms, and we happily share with them the projects, and we collaborate with them as well. So so today we're talking about these new design technologies that help us to pretty much simplifying the complexity of the project. So we use a computational tool to try to break down the complexity of the projects, whether that complexity is in form, in program, or fabrication techniques. We try to break it down into more understandable pieces that help us to reduce the risk, and also obviously optimize the construction. So we're going to focus on that today. I just want to share a couple of examples from one of our latest projects. If you were in the last session, you probably already see these slides, but we're very proud of the result of this, so I just want to share it with you. So this is a project that we've done recently in Vietnam. It's a large aquarium project that have many different complex situation and complex elements in the project, and we use ArchiCAD and Rhino Grasshopper to solve some of these complex architectures and interior design features. One of these cases is this Voronoi ceiling feature. As you can see here in this image, this Voronoi ceiling is covering a complicated part of this or a complicated space. The shape, the form of this space, it's actually doesn't have really any form. It's the result of joining several spaces that are like coming together in this one place, and it was very difficult to find one direction to create like a more rational type of false ceiling, and at the same time it just needed to be also an open ceiling due to the fire regulations. So we ended up using this organic form, which is the Voronoi polygons, because it was the form or the geometry that will adapt to this formless space. So at the beginning we use a random set of points that will create a nice shape, but very you can see here the result of this first iteration. But very rapidly, when we had to start doing the documentation for the technical stage, we discovered that it was not created in a very optimal manner. The geometry was very random, was too random, and it would be super complicated to construct, to define, and to manufacture all these different pieces. I think the rule of thumb is if it's difficult to draw and it's difficult to model, it will be difficult to construct. So we try to optimize this by using a tool called Wallacy, which is a multi objective optimization algorithm. And what we did is we set up a set of parameters that we wanted to hit in order to make this more regular. So we started from a hexagonal grid, and then we deformed this hexagonal grid a little bit, but trying to keep the areas similar, the length of the elements of the boards similar, and also minimize the number of different angles. So you can see here the result of using Grasshopper for this. In the left side, you can see the more randomized form of this ceiling, and on the right side, you can see this more refined version. At the same time, we use the tool to define IDs, to define and to draw automatically the angles, to tag all the pieces, and it was very successful. So here you can see the screen of Rhino and Wallacy working together, and each of these graphics represent how well or how bad, in this case how well, was optimizing the different parameters. In this case we were trying to optimize 4 parameters. You can see here the result. So this was very successful, and then we use GDL to create those node elements, and using Grasshopper as well to place them in our model, in our 3D model, and then the GDL object will just tell us the different angles and also the ID of the element, the location of the angles, and the type of node. This other case, we had to clad these columns in an organic way, and we use Grasshopper to create this the paneling schedule to automatically create that. And this was very anarchical. And I just want to move a little bit faster because that's the exercise that I'm gonna show you today. So in this case, what we're trying to do is solve and optimize the panelization of this complex type of surfaces. So I think we will be able to share the script later on. So if you want to play around, you need to have these plugins with you that we are using. And then in terms of the workflow, so first of all, from the design team, or the designer will define the surface and the shape of the element. So generate the generation of the initial surface. And then in terms of starting already with panelization, we want to, we're evaluating first what type of panelization do we want. Generally, quad panels are more desirable over triangular panels because they have, so triangular panels have more edges and more nodes. So that means that it will be more material and more complication in terms of fabrication and more as fabrication. But of course, triangular panels are always planar. So it's easy to fabricate, but more difficult to construct, to assemble. Whereas the quad panels are have a certain characteristics that make them more suitable, if possible, for construction. So they can be more transparent if we are working with transparent surfaces. It's easy to offset the surface itself, so it makes it more easy to define the beams and the structure and the nodes that create that have to support these panels. And also, as we said, has less material, so it will be easier to fabricate and sorry, easier to assemble, sorry, and cheaper as well. The problem is that not all the quad panels are planar. So the exercise that we are doing here is try to find within this surface what are the quad panels that are planar and what are not. So we created a very simple check for planarity, and in Grasshopper you can color these elements depending on certain properties. So in this case, you can see that yellow is planar and blue is not planar. So we simply use this, we could use different methods for planarization, but since we want to do it, it's a simple exercise, we decided to break down into 2 different type of panels. So we mix quad panels and triangular panels, and we try to minimize the amount of triangular panels. So in this case, you can see that we further subdivide the panels that are not planar into triangles. And then after that, the idea is that once we have all the panels, we need to do 2 things. One, we need to create a panel schedule, and we want also to send this into ArchiCAD. So in order to do that and to be able to identify the panels, what we do is we use these simple nodes, so these 3 nodes to create ID for each of the panels. And then this is only as part of the design. We generated this gradient color from Grasshopper. This is part of the design intent, and we want to input this gradient into our objects. So this is the overall script of design, let's say. And then we moved into the creation of the schedule. So in order to do that, what I did is break down the scripts in 2 different scripts. For that, I used the plugin Elefront. You can see the pink group of nodes there. Is like, it works similarly to the ArchiCAD nodes, just baking things into Rhino, and then we can reference things from the next file. In the next file, that is an empty file, we just reference the geometry using information that we embedded, like the name of the elements. In this case, we're searching for anything that has panel in their name, right? And then we can also get the attributes from the other file, like the ID and also the colors. After that, we find the normal vector to each of the panels in order to later on apply the transformations. And we also corrected this normal vector because we want to have a proper alignment for our panels, and these vectors are moving in the space in a random manner. So, well, not in a random manner, but following just the inclination and the angle of the panels. So we want to align those panels so they look flat in our schedule. So it's just what we did here is we found the largest edge, and we set that edge as the x vector of our plane, right? By doing that, then that edge will be facing down in our schedule and everything will be aligned. You will see in a minute. After that, what we do is measure all the sizes of the different panels and create a rectangular grid that uses the maximum value, the maximum size for the panels, in order to be able to fit all the panels inside the grid, obviously. So we set this grid a little bit far from the origin by using a point to set out this grid. And then what we did is compile in one text element the name of the panel and also the color, so an RGB value. We could also, by using Python, easily map this RGB color into a RAL or a Pantone or something like this. After that, what we want to do is send this object to ArchiCAD. So by that, we created, and this is an ongoing project, so it's not finalized yet, but we created this GDL object that it's able to generate these panels within ArchiCAD, retaining the color and retaining as well some of the properties. You can see here the nodes that we use on the side for sending this object into ArchiCAD, and on the left side you can see the result. So in the ArchiCAD screen we can see the panels. Some of them are rectangular, some of them are triangular, and they retain the color, which was one of the desired features of this panel, without creating new attributes. So the color and the color and the material, it's an internal property of the GDL object, and that really helps to not mess all your your file attributes and your template. You can see a few views of the ArchiCAD screen, and here you can see how as well all the different properties and parameters are within the object, and this will help later on. This is not ready yet, but our idea is that we can use this object that we are developing for creating schedules and also displaying all the different properties that we want, like the ID properties embedded from Grasshopper, like tolerances, things like this. So this will be able to be scheduled in ArchiCAD. Also, we're experimenting as well with this GDL object, so it can display as well the coordinates of the different nodes for structural coordination and for assembly as well. So you can turn on these coordinates. And also the elevation, not only the 3D, but elevation and plan retain the color as well. At the end, what we want to do as well is have this schedule in ArchiCAD. So since the object was not ready for scheduling yet, which will make it really easy, what we did is a strategy, a small workaround. and then we use all the projected elements with their ID in the Grasshopper screen. We just send it as well to ArchiCAD by creating the schedule itself from Grasshopper. So a polyline will define the grid, a fill will define the shape of the panel, and then we will embed using the text object, just the name and the panel name and the RGB, and we send this into a worksheet, so we can have these panels defined. Sorry, in this case, not. We could have done it into a worksheet. I did it into a floor plan, so we can have also the schedule defined here. Obviously, we can add more things from Grasshopper, like dimensions or other properties. But in this case, you can also use this schedule for not only for documentation, but for fabrication too, if needed. So this was my workshop for today. Much more interesting things are coming now, so stay tuned. And if you have any question, please post it in the chat, or we can discuss it in the QA session later. Thank you very much.
Okay, so now we'll have Carlo presenting. Carlo, up to you.
Okay. Can you see my screen?
Thanks, Roger. Amazing presentation. Again, you never cease to surprise us.
Yes, Carlo, you can see my screen. Okay, sure.
Yes, Carlo, you're ready to go. Please go ahead.
Okay, thank you, Jorge and Marcelo. So my name is Carlo. I'm a BIM consultant in Graphisoft, Singapore and Malaysia. So I'm here to present computational BIM for manufacturing. But first, let me show you the previous session we had, which is computational BIM for design and documentation. Okay, so we had showed you how to use Param-O. So for those who don't know Param-O, so Param-O is a new features in ArchiCAD 24. It's a node-based technology for object creation inside ArchiCAD. So this is quite similar to Grasshopper and Dynamo. And some features of Param-O. So it's a fully node-based parametric content creation. It has a live preview of final object during creation, and it saves the result as a parametric object. Of course, you could actually define the pen, surfaces, materials, and some basic shapes, and of course, mathematical operation as well. Then technical details of Param-O. So Param-O stored in the embedded library as a .gsm file. So .gsm file is a native object format. Then next is the Param-O script is stored in a new part library section, and then create objects are usable without installed Param-O add-on. That means you could use the object even if you don't have Param-O installed. Okay, so during the exercise, we had created a simple object in Param-O, which is the LED light object. Then I passed this object to Jorge from Enzyme for his project. He used this object to do his magic in ArchiCAD Rhino Grasshopper workflow. Okay, I had some screenshots from Jorge's previous presentation. So they used this Param-O object to create this kind of automation. Okay, so then after that, I took over on the project and then used this model to automate the documentation part. So my plan is to automate grid naming, automate object element ID naming based on the grid ID. Okay, then this simple diagram, actually this is the method we use. Basically, we use the grid X and Y coordinates and use that data to name the object. So we managed to achieve this by using the object bounding box and create a condition similar to geometry in the set. Okay, so let me show you the video. This video shows the summary of what we have. Hold on. Let me know. Okay, so this video is a summary of what we have done in the previous event. Basically, what we had showed you here was automating the element ID of the LED lights based on the grid name, which is marked. Then the first challenge here was to automate the grid naming, of course. Then once we had that grid name, we could now use that grid ID to the object ID, which is the LED light. So this is based on the object bounding box, as I mentioned. So we use the X max, Y minimum, X min, and Y max, as shown in the previous slide. So as you can see, it does the magic in one click. Okay, let me forward this one, and then yeah, that's it. So actually, computational BIM helps a lot to boost your productivity. So I remember last time when I worked in Park Associates, I used actually, I think 3 laptops and 2 desktops side by side. Those machines I used to run my script. Then while I'm working with my modeling, so the it's running. So this is really productivity boost. Okay, so for those who don't know, we have this documentation for Python as well. Just check our website. Then let's talk about a little bit on the interface before we go through the script. Python user interface is really straightforward. You just need to go to the work environment, making sure that you enable the Python palette. Then after that, you need to go to the window, palettes again, then turn on the Python palettes, and that's it. Okay, then yep. Okay, let's move on to the main topic, which is the computational BIM for manufacturing, which again, we will be using Archicad Python API and BIMx for this exercise. Okay, so in the previous event, we had showed you how Archicad can handle full project cycle, but of course, I'm not gonna show all of that. The main focus of my presentation is related to BDC. So I presume everyone knows virtual design construction, but for those who don't, let me share some notes. So stakeholders can easily access information on the fly. For example, if you have components, dimension, position, IDs by simply scanning the QR code. And with the help of BIMx application, we could easily track project information real time. So this helps better communication and collaboration to all stakeholders. Okay, so let's move on to the technical part, which is the main idea of this automation is to auto-generate QR code using Archicad Python. So before you could do that, make sure you're using Archicad 24 and you have these Archicad 24 libraries, Python libraries, I mean, not the general libraries in Archicad. Then you need to use these another libraries, which is a QR code 6.1. Okay, so I'm using this one to generate and automate the QR code. Okay, so what is the plan? So the plan is to extract the unique ID of the element and add the hyperlink. Then get the element ID. This is the one that we automate in the previous event. Then use it for QR code captioning. So what I mean by QR code captioning is something like this. Okay, you will have this element ID on top and the QR code. So that is a plan. Then some few notes here. Okay, before we run the script, make sure you know how to edit the BIM link or BIMx hyperlink. Okay, this is a simple explanation in our help center. So the blue color is the BIMx model name, and then the green color is the element ID. So this is important. this hyperlink we need to hard code our script, and the rest will be automated. Okay. Then then let's start. So first thing we need to do is select a specific element, which is the LED light. That is our first action here, as shown in the code snippet. Then after that, we need to extract the information like unique ID and add the hyperlink. Of course, we need to get the element ID as well. So what we did here is we create a for loop and generate a QR code. Next is use the element ID now, since we have the element ID. So we need to get this element ID and create a QR code caption on top. So by using the Python library's QR code, as I mentioned earlier, so you could actually easily set the caption name, size, height, and select the font size as shown in the code snippets. Okay, so again, this is the QR code captioning. Okay, next. So the last part would be we need to find the location where to save the image. Of course, we need to set the file name as well, and what type of file means. I'll be using image for this exercise. So you could actually use JPEG, PNG, and so on. But of course, there are lots of many ways to produce QR code. It could be in HTML, PDF, CSV, and you can actually put a QR code in Excel. Okay, using the CSV Python. Okay, so I'll show you the video how the script works. Okay, so as I mentioned, I'll be using the same project which I used in the previous Computational BIM event. So remember, the first thing I need to do is extract the unique ID and the element ID. As you can see, this is the unique ID and the element ID. Then next step is to save the script we have created. And then save it to the folder and open up your ArchiCAD Python palette. Okay, hold on, I think my computer hangs. Yep, okay, so save as. And then after you save, you need to go to your Python and open up your Python palette and then run the script. Okay, so just focus on the file explorer on your upper left corner. I choose that directory to save all the QR code image. The folder name is generated QR code. So let's wait for a while, as we do have like almost 500 LED lights object inside ArchiCAD. So if you do it manually, this will definitely take time. So imagine you have thousands of elements that you need to manually key in the values. Okay, so with the help of ArchiCAD Python API, it could be done in a minute. Depends on how many elements you have. So what I normally do in my previous company, as I mentioned, so I use two laptops. One is for running the script while I'm working on other stuff. Okay, this is a really good boost productivity in the company. Okay, as you can see, most of the QR code has been saved already. Okay, so now I think it's almost done. As you can see, it auto-generates QR codes with caption. This is based on the ArchiCAD object, which is the LED light. So it's the same object that we used in the previous event. So what we did is automate the element ID, right? Now we automate in the generation of QR code based on the. Okay, so let me show you the final product. Hold on, it keeps loading. Forward this one a little bit. Okay. Yep. Okay, so this is the final product. Okay, so we have this QR code plus the element ID. Okay, so I think the next step we need to do is publish the model, and then we need to upload the BIMx model to BIMx model transfer site. This is for SSA user, if I'm not mistaken. You're allowed to upload model up to 5 gig, I think. Let me show you how to publish and upload to the BIMx model transfer website. Okay, so this is the one. Again, I think this is for SSA user. Okay, you can organize into 8 folder inside, and then of course the maximum is 5 gig. Then you could actually set the privacy, like for example, set to public or private. You can actually even set password on it. Okay, let me show you that. Yep, there. Okay, so this is the exact model that we're gonna use later in our exercise. Okay, so next, so what is next? Okay, so it's the time to test the QR code. So that is to scan and verify the element using BIMx. Okay, so that is a plan. Okay, so just a quick recap. So what we did in the previous event, automation of element ID using Python, and then we managed to auto-generate QR code using Python. Then the fun part would be scan the QR code and verify the element using BIMx. Okay, so we're trying to achieve this diagram, but we're still under production. So I think in the next event we will show some digital construction. But this is the general idea. Okay, again, so just to remind you that you need to update your Python script based on your BIMx name. Okay, so you can assign BIMx name in your Python script and use the same name before publishing to BIMx. Or what you could do is publish the BIMx first and then update the Python script. So it's up to you which one you like. Just make sure you use the correct BIMx name. Okay. For those who want to try, you can scan this QR code and download the BIMx file. Okay, so we need to sign into the BIMx model transfer website to get our model, but we have this QR code that will direct you to the BIMx app and the model. So, but before we do that, let me show first how the script works. Okay, how the scanning and verifying works. So let me play the video here. Okay, so scan this one. Okay, first thing you need to do is, of course, go to the BIMx model, your BIMx app. I mean, just click the plus icon and then go to the BIMx model transfer site. So search for the Firefly and start scanning the QR code. So the name of the model is Fireflies, and then it will go directly to the website, and you need to download it. Okay, just click download and open. Okay, if you scan the QR code here, it will direct you to the model and installation as well. Okay, so once we have this model side, we can now try the QR code. Okay, so this is like a cloud, the BIMx model transfer site is like a cloud service. So where you could use the service server space offered by Graphisoft, especially for SSA user. So this is where you could upload or download BIMx model to your phone or tablet. So once you have the model inside your BIMx, just go to your camera and then scan the QR code. Then it will prompt you to open in BIMx app. So as you can see here, right? So it automatically zoom in and show you the element based on the QR code you scan. Okay, again, this is very useful, especially in manufacturing. Okay, so again, I'll try to scan a few QR codes here, and then you see the BIMx prompt, right? Just click that one, and it will zoom in where is the location of that element. Okay, if you click this and then check the info, then you can see the element ID, height, depth, and some other information. Okay, so for those who really want to try, please scan this QR code. I'm not gonna hack your bank account, don't worry. This is a Graphisoft BIMx application and model. Okay, so once you guys install your BIMx application, so try to scan these QR codes. This is the exact QR code I generated earlier from the model. So you can try this and then scan. Okay, so I will give you a few minutes to try, or maybe I think my presentation is up. So yeah, I think that's it. So I hope everyone try this in your phone. I'll be sharing some QR code maybe during your lunchtime. I will just flash the slides on the screen during break time and to try it. Okay, thank you. And let me pass it to Marcelo.
Thank you, Carlo. Really amazing stuff. So everyone, I was actually following here and repeating the same steps. So now we will have a break. I think we are a bit ahead of time. So I think that we can make the break 20 minutes. So we could start at 4:10. And yeah, so for this, we'll just resume in about 18 minutes time. Okay, looking forward to see everyone back.
Okay, again, for those who want to try, just scan this BIMx model here and then scan the QR code. Okay.
Yeah, I was gonna share my screen, but I better I can leave it here so they can test it during the break.
Okay.
Okay,
great.
So catch up with you guys soon. Great stuff, Carlo. Really interesting that everyone can download and get the file to test out for themselves.
Thanks. Bye.
Okay, so see you all here in about 17 minutes. Okay, so good afternoon, everyone. Welcome back to this session on computational BIM for manufacturing and fabrication side. So to recap a little bit on what we have seen so far. So we've seen Jorge showing us how we can take the design and optimize it for construction purposes. And then later, Carlo showed us how we can get access to the data of the BIM model and then break it down into almost element level so that we can reach it out using QR codes or any type of tagging so that for fabrication and manufacturing, this can be used and easily we can track down. I can see many different reasons or many different usages we can take on this. So for example, we can control if the elements are already assembled or not, or we can have just a data sheet for each one of those elements that are on site. Let's imagine it's a lamp fixture or something, or even air condition that would need some servicing to be done. So if we can, by having these QR codes, attached to the model, we can use the BIMx visualization for this. So we have here.
The BIMx solution has enabled our designs to break free of the confines of the desktop and even of the studio itself.
So these testimonials also show other usages we can take on BIMx.
Which is fun. We put it on the iPad Pro. We could take it to all of our construction sites. We can upload it to a cloud. Our entire coordination team can download that. These are folks who can engage our design, structural engineers, expediters, general contractors, even real estate salespeople. It enables them to engage the design in a much more visually rich way, in ways where they wouldn't have read plans before. They wouldn't have unrolled our giant drawings before. We would have had the email attachments of a rendering, but now they have any angle, any view at their fingertips.
So basically with BIMx, this revolutionizes the way, not just how you access the data, like element by element, like how Carlo has shown you, but also like the whole integrated model in one platform that makes everyone reach it or read it very easily. So what are the other places or the other platforms that we can have BIMx? So we can also have it embedded in a website. So BIMx has a web viewer. So just by taking the link, you can embed it on your it could be a project email, project page. It can be your company page. So by using this technology, you can still navigate, jump through the drawings, and even check some information on the elements. Okay, so with this is really the focus is to ignore the old way of bringing information across. So digital doesn't mean just only saving paper, but it's also having access to more data. So as we've seen previously, we can also get element information. We can also take advantage of all these platforms, of all this amount of data that we can feed, so that we don't need to tag a drawing with 10 or 20 different lines of information, but just by tapping on an element, we can query the model for what relevant information we need from here. So this here we can see that just how this is done just by tapping on it. Then we can scroll with our fingers and get whatever relevant information we want to get from the model. So I'd like to share also a little bit of a personal experience. So by using this kind of method of storing data, classifying elements, you can see here I have it's a quite project done a few years ago. This was to ship in containers the structural part of this building, and we tested by those who know Tekla. This was using Tekla to color code the different profiles will come in with the IFC in different colors. So we would like to tag each one of these elements, and by using the listing of ArchiCAD, we actually tagged each one of these elements, put it in a container, and then being shipped, so that this way when they are assembled, they are properly tagged, properly numbered, so that they can be used in such scenario. So obviously nowadays, this was more than 8 years ago. Nowadays, with the technology available, we can use more cloud workflows based, such as using even the messaging on BIMx, using, let's say, even the graphic overrides that will show you the different stages or the different elements or the order of assembly. So even 4D sequencing could be controlled by using such kind of technologies. So I think that with this and with the recap and other ways that we can take advantage of this BIMx and breaking down of elements for fabrication methodology, I would like to give now the stage to my colleague, the Director of Customer Success for BIM implementation, Chidambaram.
Hi, thanks, Marcelo. Thank you for the things. Thank you very much. And yeah, the BIMx QR code is very useful. Thanks, Carlo, and thanks, Jorge, for your presentation.
Yeah.
So let me share my screen.
Yeah.
Okay. It's coming soon.
Okay.
Can you see my screen? Yeah.
I think is not yet being shared.
A bit slow. Yeah.
Yeah, I think it's still mine. Okay, I think yours is now in.
Can you see it?
Yeah. Can you
Yeah,
change?
it's my slide now.
Yeah, now is yours. Please
Okay.
go ahead.
Okay. Sure. Thanks, Maslow. Thank you. So let me first, I would like to thank BC also for giving us this opportunity. I hear from Pong that they have done a survey and they want to see how MEP engineers can also leverage on this kind of solution, computational BIM solution. And he have given us a few problem statements. And one of them is on the lighting placement and things like that, which Carlo already have shown. And I took on the other one, which we did it in an actual project to place inspection chambers in the model. And once you have the information, we can actually generate the documentation also necessary for the thing, right? So, is in my slide? It's not moving.
Yeah, it's not moving. You want to share again?
Okay, let me share again. Can you see it now?
Yep. It's showing, but it's not changing the slide.
Okay, now it's changing.
Yeah, now it is. Now it is. Sure, go ahead.
Okay, thanks, Maslow. Thank you. So the problem statement is, yeah. Can you hear me also? Okay, clear?
Yes, perfect.
Yes. So the problem statement is basically how to place the ICs based on the gradient, right? So there is actually a gradient between each IC, and number of ICs also will differ based on the distance between each IC. You have to calculate everything manually, right? So every IC based on the distance between them, and after that you also have to calculate the length of the pipes, and you have to identify the starting point and ending point. Again, this need to be done manually. So after you have all this information in the planning, you can start placing the elements, and then you have to do this. So basically it will take easily, even the expert guy to do it, it will take a half day or even 1 day to place for each block, right? So calculating the things. So one of our customer asked whether we can solve this with Grasshopper. That's the time we try to use Grasshopper to achieve this, and we managed to do it. The final version of the thing was handled by the customer, so it is a bit different from the thing we are sharing here. So it is not the exact same thing, but the gist is here, right? Before you start doing, you don't need any additional package in Grasshopper. So basically what you need is some special objects in ArchiCAD, like what Ortiz shared earlier. We need to create special objects for this. We have created an IC object, and this IC object is available for SSA customers in Singapore, right? And Malaysia, we have this. Basically, this object comes with all the necessary parameters. So what is the top level? What is the invert level? What is the size of it? Is it a 2 opening one or single opening one. All this information is there. On top of it, it also has the 2D annotation information. Like you can see here, top level and invert level are marked, right? So this object is created by our team. With this object, we can actually control that with a Grasshopper. So it's very similar to what Jorge has shown on the first side, but we are doing it in MEP, right? So we are doing this in MEP. Additional to it, so the MEP elements, the pipes comes with ArchiCAD, doesn't work with Grasshopper. So to overcome this, we decided to create a pipe which is required for the layouting. We have created a pipe which you can set the diameter and all, and on top of it, you also can decide the run and the ratio, run and ratio, you can set it. So the sloping will be taken care of automatically. So no need to worry about the sloping, right? So this object also created by us, especially for this market. So once we have these two objects, so the next step is to go into the solution development in Grasshopper, right? So it is not a very complex solution. So it is just a few parts I will explain to you in the Grasshopper part itself, right? So let me move on to the demo part. And in case if you guys need this script or objects, you can reach me on this email. Some of you already know my email. So if not, later I will share in the chat. You also can reach me, and I will share the objects and the script for you, right? So let me switch to ArchiCAD and Grasshopper so that we can show what we have done. This is ArchiCAD. So I have a simple mark to show this the building, right? And I have ArchiCAD Grasshopper running on the side, right? So let me focus on the components. So these are set up the components we have to control our design, right? So it controls the distance between the ICs. So I can just slide it. So I can slide and set it, or I can double click and I can key in my distance, right, between them, right? I don't know whether I should do this. One more, and I should click on the tick, right? So okay. Then you have the first IC's depth. This is like a guidance for us. From here, rest of the ICs will be controlled. So this is actually starting depth, all right? So that's a starting point. And then we go into the slope. So the slope part is actually defining the pipe's slope. Based on this, the gradient of the IC and the level, invert level of IC will be calculated as well, right? So these three are the control point for this entire script. And if you look at here, this is the input here, right? So this is the input, which I can get it from ArchiCAD. And here, further, I will be processing it. So let me connect ArchiCAD and Grasshopper. Okay, so currently there is no point selected. So we have to pick the points in a sequential manner. So I will right click here to select the points. It's a bit slow, sorry for that. So I'll just say I want to select multiple points in ArchiCAD, right? So then I come in ArchiCAD and I pick the points I want, right? So I would say this point and this point. I'm picking in a sequence, right? So you can see here. So these are the location of the ICs I have decided, right? So in case the distance is too much, it will add additional ICs in between. So once I have selected, I will go back to Rhino and Grasshopper. So it will load the part. So you can see my input is already in, right? It is running. So let me wait for a while. You can see it already places the ICs and the pipes together with the annotations. So for the pipes, it will give the length of the pipe and the gradient of the pipe, right? So basically how I get it is basically from this input, I form the lines between the points, right? So I also do a verification here to check what is the total length and what is the division, right? The slope, sorry, the slope I will check here. So there's the verification to check whether it is okay. Then after that, I will take in further, and I see here there is a place where I decide whether there's a need for extra ICs in between or not. So at the point here is 6, but if there is a need for extra based on the input, I will insert additional points for the IC, right? So there's in between points I will be inserting. So with that, I need to sort it out again because there are new points inserted. So I need to resort the whole thing here, right? So I'll do the resorting and also check the information again, verify the information again to make sure it tally with the beginning, right? So after that, I will do the sorting and generating the things, right? So you can see you will get with this part, you will be getting the depth of each IC. Again, I don't see any suitable components for this in Grasshopper. So that time I decided to write my own VB. Of course, if you know a little bit of Python, like Calo, or if you know VB, whatever you have, you can actually write your own component. So when I double click on it, it will open up, so it doesn't crash. Okay, let me see. Yeah, script editor is open. So you can see this is actually a VB script. Basically, I'm taking the input, the initial depth and the increasing depth, and I create based on the number of ICs, I'm creating the depths for each IC. So it's a very, very small VB script. I write it inside here in Grasshopper, and this can be used to output the depth of each ICs. So you can see here, now it comes with the 7 ICs, and each IC starting from 1005, it is keep increasing until it gets the final IC, right? So once we have this information, so now it's time to place the pipes and the ICs. So again, as shared by or here from Enzyme, on the left side, you can see all the parameters. Actually, I'm passing these settings. So basically the depth I'm passing in for this IC, and I'm placing this IC object. As I mentioned in ArchiCAD, we have created this IC object. I'm placing this IC object in inside the ArchiCAD, right? So next is the pipe part I'm taking in. I'm also telling it need to be placed on the ground floor, right? So it need to be placed on the ground floor. And also the angle, because sometimes we need to calculate the angle between the 2 points, because it is also rotated in the plan and also in the elevation, right? So both sides we are calculating those things, and we are passing that input also here, right? And also the necessary properties we are passing here, and we are placing the pipes. So we are calculating the points, each points we are calculating it, and we are placing it here, right? So these are the pipes. So if I select it in here, you will see those things are selected in ArchiCAD. Let me see. So it's showing in Rhino. So if I select it, these are the ICs, yeah. So you can see the ICs are selected, all right? And if I select this, so this should be the pipes. I want to do live, but I'm also scared go to meeting together with the live. Sometimes it may crash, right? So that's the thing. And if I select here, I do another thing. This is also for the verification purpose. So I draw a line first to check whether the line forms correctly or not, right? So I do that. If you don't need it, you can actually remove this part. You can don't create this part if you don't want to, if you want to skip it, right? So this part is also available, right? So there is a these are just used for verification purpose only. So these are additional checks, right? So if you don't want these things, you can actually remove it. These are actually simple it's a very simple script. It can be done by anybody. You don't need a computer programmer, right? So I'm not a programmer, by the way. So you can actually see this created, right? And if I go in here in ArchiCAD, this is already placed here. And now if I change, say if I want to see it in 3D. So I see here, you can see the things in 3D around the place, right? So what if I change something? So I want to change the distance between them. So if I change this, so I want to make it, so the distance between the IC side, make it different. So hope it doesn't affect for me. Yeah, when I do it online, it's a bit, you can see, it places additional ICs in between, all right? So you don't need to worry about the placement of additional ICs, recalculating the thing and putting in again and things like that. So you always can use this control to change it, right? So if you don't want to control that way, you can actually enter this also directly, as I mentioned earlier. So you can actually enter and fix it, right? So that will go back to the original design, right? So this basically the thing, and very easily, once you have this as a recipe, you can do it for any number of buildings, any blocks. So this IC layouts, and IC is the inspection chambers and the pipes running between them in a particular slope. So this can be done easily by anyone, and this concept you can apply for other architectural or structural designs as well, right? So it's not only for MEP, but here we are using it for MEP, right? So this can be done for other things as well, right? So if you want to know more, I will be there to share with you during the Q&A session. We can actually see more later, right? So I think I'm also finishing it a bit earlier. So let me open up for discussion. Maslow, you have any questions to ask? We can discuss before we go on to the next presenter.
Nothing specifically. Just have some people saying good workflow. Another thing is there was some issues about getting the BIMx to read the QR codes. Now there was a few changes, so if you try the follow what's on the chat, so if you use the BIMx lab, you can test those things.
Yeah, for Android, I learned from the team BIMx lab works fine in Android, right? So yeah, so yeah. Okay, is asking how much time roughly did it take to program the GDL objects. So the GDL objects really depends on the parameters we need to create. So I can just show it to you the object itself, right? So if I select the IC, so if I go into the settings, it's actually done with a simple morph actually. So if I show it in 3D, you can see it's actually a morph with a gap inside with a cap, and we added in these settings. You can see the clear width and the length plus the depth here, right? So wall thickness and things like that. So this IC you can straight away use it in anywhere, right? So basically for IC is cast in place, so they will not have a connection for the pipes. So it's much easier to do for this workflow, right? So you can actually get it done. And also like when you want to show the opening or no opening, you can actually enable that, disable that. You can see there is no opening is shown, right? So we have some tricks also. So this part we can do it within both the pipe and IC. It doesn't take much time. Hope I answer you. Okay, yeah.
Yeah.
And Gary is asking when you want to change the top level of the IC, so will the 3D automatically adjust? Yes, you can. Actually, we are just using the level from the 104 is actually the project level. So we are placing it on that level. So it is always calculated from that placement. So you can see here we are placing the object in the 0, means that it is actually coming from the project setting. So if you go to the options and project preference, you can see for the location, it should be coming from there. So you can see this 104. So it is taking from there. If you change it, then the objects will be placed from that level. This is for Gary. Yeah. So if you want to change one IC, then we have to tweak the Grasshopper a little bit. So currently it is all placed in the same ground level, right? So if you want to tweak, that part is not added. We can actually add that to the Grasshopper script. If there is a set of different set of levels, maybe this happens in areas where you have terrain that have, you know, multiple levels, then you may need to do it. But at the moment, this script we haven't added in that part, so we can actually add that part if you want to. So the placement of the IC can be controlled. So currently, I'm not giving the input for the IC placement. If you see here, so we are not giving the input. It is placed directly in the place. Yeah. So the placement is coming from here. It's all. So if I select it, it goes into here. You can see everything is in 0, right? So if I show here the list, you can see all the values for the Z value is 0. So if I need to calculate the terrain level, definitely it can be calculated, and we can add the Z level for each IC. And then we have to pass that information to the VB script so that the depth will be calculated from that point. Then it will place the IC accordingly, right? So it is possible to do it.
Yeah. So basically, this I also like to highlight here that this is to show some of the potential. Obviously, these scripts could become, you know, very appropriate to any single iteration you would like to have, or any action you would like to have. Is here we try to keep it simple, just to focus on one specific approach.
Yeah, because of the no, we have participants from different expertise level, so that's why we want to keep it very simple. Yeah.
Just to show the possibilities. So Jorge is saying that if you have the coordinates in TXT or Excel, you can directly import these to the Grasshopper script.
Yeah.
And if they change in your model, you can have that being read constantly like this. So not everyone has to know Grasshopper. Good one. Yeah, Jorge always can come out with the script out of the blue.
Yeah. So then you read it. So the input is coming from the Excel. So the users just edit the Excel, and then you will get the design out, right? So you don't need to really know how to do Grasshopper script. Yeah.
Okay. Perfect.
Yeah, okay.
So I think that we're just
done.
We can move on to Rima. This is the last presentation before the Q&A. Thank you very much, Chidam. I think it was very enlightening to see that we can also use this for MEP side, and we can come up with very interesting workflows. So, Rima, can you on your camera so it's easier for me to find you?
Yeah, she's there already. Thanks, Rima. Thanks, Maslow.
Okay, perfect. Rima, so up to you now. You have the screen, you can share now. Perfect.
Okay, so good afternoon, everybody. Is the screen visible to all?
Yes, perfect.
Okay, great. I hope you all have enjoyed the presentation so far, and we had such brilliant sharing today. So my presentation today, we have this idea of integrating the information that we have gathered in ArchiCAD and bring it into Power BI for presentations, for reports, for sharing the data with other collaborators, and especially people who would not want to open the model to look at those information and still want to gather and analyze. So let's have a look here, and for this purpose, give me a moment. Yeah. So basically, this was the idea to enable the manufacturers and also in the management to make informed decisions by communicating BIM data in a visually intelligent and intellectual manner without requiring to open the BIM model. So how are we going to do this? First thing, let's talk about the tools that we will require for this purpose. Definitely, the model authoring tool in this case is ArchiCAD. And we are going to use Python to extract the information from ArchiCAD and bring it inside external data source, which in this case will be MongoDB. And then we need a connector from MongoDB to Power BI, and we will be using ODBC to transfer the data from MongoDB to Power BI. So Carlo already has explained about setting up Python, and if you're interested for a recap or going through the session again, please make use of the QR code or the link on the screen right now to go through all those things one more time. So let's talk about MongoDB a little. So for this presentation and also for this workflow, we are using MongoDB to exchange the data. So my colleague Chidam has actually helped me with the Python script to extract the information from ArchiCAD and to MongoDB database. You can actually install MongoDB from the link on the screen right now. We have used MongoDB Atlas for this purpose, which is actually a paid version. But if you're not looking at integrating with Power BI, you can also use MongoDB, the free version, to store data from ArchiCAD. But in case you're looking for integrating or bringing in Power BI for visual representations or generating report, you would need the paid version. And you can go to the link to find out the price for that. So we researched on this workflow, and we have taken help of this particular website, w3schools.com. In case you are interested in learning the same, you can also make use of this link and go through the recommendations there and the literature there. So now let's have a look on how are we going to bring the information from the BIM model to Power BI. So for this purpose, we have two workflows. The first one is automated, which is the main focus of today's sharing. And the other one is actually manual. So for automated, we are going to transfer the information from ArchiCAD using Python script, transfer it to MongoDB, and then the information goes to Power BI. The other one is manual. From ArchiCAD, we are going to export the information in form of Excel, and then we are going to store that information in other cloud platforms like OneDrive or SharePoint or whichever is useful to you. And that's how the information is going to transfer to Power BI. So the main difference here is going to be in case of updates, where the information in the BIM model is actually ever changing. So when I'm running a Python script, the data in the MongoDB is automatically updated. So I do not have to every time export manually the Excel from ArchiCAD and upload and replace the existing file in cloud. So for this purpose, what Chidam has actually done is he has actually installed these two packages, PyMongo and DNS Python. So PyMongo is actually for using the functions to work on the database, and DNS Python is to connect with the database. You can use the syntax shown below to install these packages. Now let's discuss the Python code. So the first snippet, what you see on the screen, is actually importing the necessary packages for this solution. And the next one is actually connecting the MongoDB to a specific database with a connection string and the two variables that is going to store the database name and the table name. So the database name in this workflow is ArchiCAD data, and the table is element. So later when we connect to MongoDB, we will see that there. Okay, so you can just use the information here, and this connection string is going to get from MongoDB portal as shown below. Okay, so the next step would be to connect ArchiCAD and create the key components required to access the data. And then we are going to get the elements using these commands. And the last would be to indicate what are the properties required by passing a string value. This will store the user IDs of these properties in an array. And moving forward, these stored properties, which we have just got by the elements, and it's going to be stored in a dictionary format. The next one will be to process the property values in the dictionary created by the first snippet and upload into the MongoDB. It creates a dictionary for each row and document and add it to the table. This will also delete the existing data to make it clean. And lastly, we have to the snippet is going to get the data and print to confirm. I have a video here to share with you all to see how it works when we run in the ArchiCAD. So here's our famous S building. So what we are going to do here is run our Python script here, bringing on the Python palette first. So that's the script that we are going to run. And it is going to gather all the information that is required, and it's going to clean up as well the script. So you can see it is gathering the element type, the height, the width, and all the information associated with the element. And that's a peek into MongoDB. And if you click on collections, it will show you the gathered data. So that's ArchiCAD data and the table element and the required information all inside. Okay. So that's about migrating the information from ArchiCAD to MongoDB using Python. So next part of my presentation is going to focus on transferring the data from MongoDB to Power BI using the ODBC connector. Okay, so let's have a look at the Power BI product variations first. For this purpose, we are going to use Power BI Desktop, which is the free version and is quite good enough to extract the data and present it and create the visuals and share the report using share the report as PDFs and also to create a dashboard. But in case you're looking for more, meaning like if in case you want to share the dashboard created with other users, you might have to look into the paid version. And for more details, you can visit the website to find out. Well, as far as Power BI is concerned, you do not need any extra expertise as long as you can enter, edit, format text and numbers. You're able to format tables, find and replace, sort and filter data, insert and format charts. You're good to go. Let's have a look at the workflow. So what we are looking here is the information is already stored in MongoDB, and we will have to install a connector, which is ODBC in this case. So what exactly is ODBC? ODBC is actually a connection between MongoDB and Power BI. So it actually enables the flow of data from MongoDB to Power BI. And there's a link below where you can find the information about downloading ODBC for this purpose. The next step would be to clean and filter the data after it comes into Power BI and create the required visualizations for the purpose of sharing. And lastly, when you want to share the data, or when you want to share the visualizations, you will be creating either a dashboard or you will be exporting the information, exporting the visuals as PDF. Now let's have a look at a MongoDB connection with ODBC. Sorry. So this is the MongoDB interface. Once you have created the account and you have added the users into it, you will be able to create a cluster. And when you create a cluster, the information is already there. You can click on Connect. It will take you to another window where you will find Connect your business intelligence tool. And once you click on it, it will provide you the data as host name, port, user, which you will be using in your ODBC data source network. So once you have installed the ODBC data source, you just have to click on Add. It will take you to the data source network. And once you click on Finish, you can add in all the information that you have gathered previously to these tabs here. Now, I would like to bring you to the Power BI interface. So that's the Power BI interface. And at the moment, what you see on the screen is currently blank. So what I'm going to do is I'm going to get the data. My connection with ODBC is already established for MongoDB. So I'm just going to click on More. It might be a little slow, so just bear with me. ODBC. So I'm going to now connect to MongoDB, and I will pick up my data source name. And here I can see that this is what I have created, and this is the information that is inside there. And I can just click on Load so that the information is transferred to Power BI. But at the moment, let me just take you to the information which I already imported in. So that is all the information I brought inside. And if I look here, the information is available in terms of fields, and I can choose how I want to represent this information from the visualization charts here. So it can be bar, it can be pie chart, it can be a table. So it really depends upon what you want to convey and how you want to convey. So I've actually created a few reports already. So that's for zones. So I've actually created a pie chart and also another representation. So one is actually telling you the percentage of that particular zone in terms of the whole area. And the other one is another way of representing the same information. Similarly, I also have for doors, and I can easily see the type of doors and the quantity. And I can actually compare the percentage of that type of door with the overall. I mean, in terms of numbers. Similarly, I also have for furniture quantity. So here I have all the furniture listed, and I can represent it in form of a bar chart or a pie chart. Another one is for finishes. Interestingly, I can actually manipulate the colors here and align them with the finishes color inside my model as well. So that it's much more easier for me to understand and relate with. So I have all the finishes here, exposed area, and the percentage. So that's what I wanted to share with you today. If you're interested in knowing more about the connection or any information related to Power BI, just drop me an email. I will be happy to share more with you. Thank you.
Well, thank you very much, Rima. It's also very interesting. So how to see how we can bring the workflow from the design prepared to the presentation to fabrication, and then present it to the results and even measure them what's being placed. So I think that with this now we can jump into our Q&A or discussion. Let me just share the screen.
Just Marcel, just a quick one I want to add together with Rima. Actually, in our last presentation when we did it in August, one of the participants was asking how to connect with Power BI. So that triggered this initiative where with the team we try to evaluate and see how best it can be done. So why we selected MongoDB is because MongoDB is in the cloud, and with this current situation, we all working from home. We are all in different place. Say, for example, if Jorge is doing the design, I want to do the reporting. All right, so we can actually use MongoDB to transport the data, and then we can do different place. We can actually work together. So that's for the whole thought about this presentation. I think Rima have shown very clearly, and also shown some of the possible reports how you can do it. So thanks, Rima, for a wonderful presentation.
Yeah. So I think that with this, James, is there anything on the chat that is worth noting or discussing?
No, I don't think there's anything additional
that
caught my eye. I think you clarified earlier about the BIMx links with Android. So,
yeah, I think BIMx always steals the show, and it becomes the most relevant topic. So yeah, I think the key takeaway from here is that the workflows is what makes us take advantage of the tools, and makes us go from end to end, and makes us be aligned with the government initiatives, in this case here in Singapore with IDD. Obviously, if you're watching this from anywhere in the world, digitalization is the way that the industry is moving forward. So this is just a mindset that we need to have in order to take advantage of these technologies. So if nobody wants to turn on the mic and discuss or ask something, I think we could wrap up here. In case anyone would like to have access to the files that we have shared here, or any further information, you can contact us here. So these are the 4 members of our team that were here. Sorry, James, you didn't put your email there. I think you're off the hook this time. And you can visit us at graphisoft.com/sg. So basically, we would like to reply or answer any other queries you might have. If you need any specific file that we have shown here, we can also discuss if we can share it with you. So please feel free to reach out to us in case you have any further query. So I see that there's some action on the chat. So James has shared his email. You want some attention?
Kihua was asking something maybe that is interesting to share.
Okay, so Kihua is asking if the Graphisoft extras can be like soccer stars that can be on loan to companies. Yeah, of course. So basically, we work very closely with our clients and with our markets. So in case you have something that you wanna tap on us, we even develop sometimes, for example, add-ons or workflows to share this. So we'll see how we can go know about this. And for you, Kihua, you can always reach out to us directly. You're a key client of this. We also have another question here that we will receive the link for the recording of this webinar. So we could put it on the link. Or Chidam, you want to elaborate more on this? We have the previous session shared. If you want something.
So I think James did answer to that. We will share this recording in our YouTube channel. We will send a link to all those register for this event, right? So they will get a link for the YouTube session we shared in the YouTube. So it is not only this particular session, you also can watch the past sessions and also some of the like tips and tricks and all. So you can watch from our YouTube channel.
Yeah, and also pay attention because if you're following us, we will be sharing the dates closer to the next 2 sessions, and this will, be nicely joined together to see the whole workflow from design through manufacturing, assembly, and then in the end to operations. So this is the idea of this webinar series. So it's exactly what BCA is aiming in doing this together with us. So we'd like to also thank BCA for this initiative that is making us the effort.
And I see Pong is there in the audience. Yeah. So we have BCA colleagues here. Thanks BCA. So
thank you, Chidam, and thank you for the speakers over here and the support, the continuous support.
Yeah, thanks.
It's always a pleasure to work together. So I think if there's no further questions, we could wrap up here. It's been a pleasure again to spend the afternoon with all of you, or morning, depending on where you are, and looking forward to see you in the next events. Meanwhile, if you want to contact us, don't be shy, reach out to us. We're very approachable.
Yeah, please reach us. So we want to transfer knowledge. That's our main aim. So we will be happy to share the scripts or content. So just reach to us if you need them. Thank you.
Thank you, everyone. Bye.
Thank you so much, guys.
Thank you. And special thanks to Jorge for joining us as a guest speaker.
Yeah.
Always happy to work with you. Thanks.
No matter where you are, even
Yeah.
Okay.
Thank you, guys.
Yeah.